All right, these are the solutions to that class kick. So the first one, this first slide, most of you did pretty good on. You're factoring these and then splitting and solving them. So for the first one, you wanted to factor. This is first times last or trial and error, and you should have gotten 5x minus 2 and then x minus 2, split and solve them. And you got 2/5 and then x equals 2. On the second one, it's factoring by grouping. And this one, you actually factored and then had to factor again. So just be careful. If it said x squared minus 4, that can get factored further. Or you can solve it, but you have to use the even root. Either way, you should have ended up with positive and negative 2 and negative 3/5. Again, most of you got this one right, so good job. On 3 and 4, now we're using the square root or the even root property. So the first thing you have to do for 3 is plus and minus the square root of 48. And then 48 breaks down into 4 root 3. And then I would subtract the 5 and divide by 3. You could have also had the order as like plus and minus 4 root 3 minus 5 over 3. That's 5. That's fine. Just be careful because some of you like the 5 was not over the 3. It has to be because the dividing by 3 should be the last thing that you do. For 4, some of you are square rooting from the beginning and that's where mistakes are being made. You want to isolate the squared term first. So I would add the 8, then divide by 5, and then square root making it plus and minus. And then that becomes the square root of 8 over the square root of 5. 8 breaks down, that would be 2 root 2 over square root 5. And then you have to rationalize the root 5. So I multiply top and bottom by root 5, and that's where 2 root 10 over 5 comes from. And then it was plus and minus because of that even root.
Does it matter if you put the x equals?
No.
So you can leave it either way?
Yeah. So on tests, like if the answer blanks, you can give me x equals or you can just give me the answers. It doesn't matter. For 5 and 6, I would say for 5, some of you kept that fraction. Get rid of it for quadratic formula, okay? So I would multiply everything by 3, and it doesn't matter if you do it before you move the 4 or after, as long as that 4 also gets the 3. And you get 3x squared minus x minus 12. So a is 3, b is negative 1, c is negative 12, and then plug it into the quadratic formula and simplify, and you should get 1 plus and minus square root 45 over 6. And again, leave that all together. You can split it, but you don't need to, so don't waste your time. Check to see if 145 broke down. It didn't. It was 5 and 29. It doesn't go anywhere from there, so you can keep it. For 6, a is 2, b is negative 3, c, after you move it over, because it has to be set equal to 0, is negative 4. And you should get 3 plus and minus the square root of 41 over 4. Overall, okay on these. Like, not great, but okay on these. The first one worse than the second one. Just be careful. And then completing the square. So for 7, you wanted to move the 15 over. Then I want to divide everything by 2 to get rid of the number that's on the front. So I divided by 2, divide by 2, divide by 2. And I ended up with x plus x squared minus 3x equals 15 over 2. Then I take that 3, divide it by 2 and square it. That's what's over here. And I get 9/4. Added the 9/4 to the left and to the right. On the left, I then factored my perfect square trinomial by square rooting the first term, square rooting the last term, taking the sign from the middle, putting it in parentheses and squaring it. And on the right-hand side, I found a like denominator here by multiplying by 2, and I added 9/4 and 30/4 to get 39/4. And then I'm here. Then I square root both sides, putting the plus and minus in front of the right. And I'd get x minus 3/2 equals plus and minus, split it up, square root 39 over square root 4. The square root 4 becomes 2, and 39 does not simplify. So then I would add the 3/2. And you could have kept it separate, or you could combine it into 1. Just be careful. Some of you just lost the 2 underneath the 3, so be careful when you're combining it.
I don't 6/4 instead of 9.
You're not, wait, 6/4 where? When you're factoring? So you want to make sure that, so you would take the middle term, which is 3, divide it by 2, and then square it. So that should be 9/4. Maybe you multiplied the top?
No, I did everything, but I still got the right answer.
Because you kept the middle, we just had this conversation, right? You kept the middle as 6/4. If you kept the middle as 6/4, it's fine. It's harder, but it's fine. Yeah. All right, just check your work on that last one and make sure you get cracking on that chapter review or the test review so that tomorrow when you come in, we can go over questions on it. Okay, so for 8, I'm going to move the 3 to the other side, and then I'm going to divide each term by -5 because it's on the front, and I get x squared plus 2x. I'm going to leave that space equals -3/5. And then I take the 2, I divide it by 2 and square it. That's 1 squared, and I add the 1 here, and I add 1, which turns into 5/5. Then on the left, I'm going to factor square root x squared, and I get x. Square root 1, I get 1. Take the sign from the middle, which is plus. Put it in parentheses and square it, and that equals -3/5 plus 5/5, which is 2/5. Then we square root. Plus and minus on the left. Square root on the left, do plus and minus, the square root on the right. And I end up with, I'll write this over here, x plus 1 equals plus and minus the square root of 2 over the square root of 5, which has to get rationalized, square root 5 and square root 5. So I get x plus 1 equals plus and minus square root 10 over 5. And then I want to subtract the 1. And you can leave it just like that, plus and minus square root 10 over 5 minus 1. Or you can combine it into one denominator, but if you're going to do that, you have to make 1 have a denominator of 5, which means it would be plus and minus root 10 minus 5 over 5. So to make it easier on yourself and you will get full credit, I would leave it like that. Just do plus and minus root 10 over 5 minus 1. Okay, and these are the last 2 examples from the notes from 1-4b. So these are still complete the square. I'm going to look at 8. I'm going to move the 1 to the other side. 3x squared minus 4x equals 1. Then I have to divide everything by 3. And I get x squared minus 4/3 x equals 1/3. I have to take that 4/3, divide it by 2, and then square it. Dividing by 2 is the same thing as multiplying by 1/2. 2 goes into 4 twice, and I get 2/3 squared, which is 4/9. I'm going to add that to both sides of the equal sign. On the left-hand side, I'm going to factor. Square root the first one, square root the 4/9, which is 2/3, or what was inside before I squared it. Take the sign from the middle, put it in parentheses and square it. And then I need to give a like denominator here, so this is times 3, and this would be 3/9. 4/9 plus 3/9 is 7/9. I'm going to square root both sides of the equation, putting the plus and minus on the right, and I get x minus 2/3 equals plus and minus square root 7 over square root 9, which is 3. And then add the 2/3. And I can either keep my answer as this, or I can combine it into one, like 2 plus and minus square root 7 all over 3. Both would be marked correct. Okay, number 9, repeat the process. Add the 1. Divide everything by 5. X squared minus 7/5 x equals 1/5. Take the middle term, 7/5, divide it by 2, square it. Dividing by 2 is the same thing as multiplying by 1/2. And I end up with 7/10 squared, or 49 over 100. I add it to both sides of the equal sign. Factor the left, square root of x squared, square root of 49 over 100, sign from the middle, put it in parentheses and square it. And then I have to give a like denominator here on the right. I'd multiply by 20. So that becomes a positive 20 over 100. And I get 69 over 100. Then I would square root, put plus and minus in front of it, And I get x minus 7/10 equals plus and minus the square root of 69 over the square root of 100, which is 10. 69 is 3 and 23. That doesn't go any further, which means I'm going to leave it like that. The last step would be to add that 7/10. And then again, I can leave it separate, or they have a like denominator, so I can also combine them together into one fraction. All right, so homework for tonight is to work on the chapter test, review, which is going to cover 1.2 to 1.4, 1.2 to 1.4a was what was on the quiz. And then we added quadratic formula and complete the square. Have a good day.